Good afternoon, everyone. Let me cover section 3.1 for my finite math people. I'm going to try not to stutter and go and ah. Let us begin. Let me look at homework question number 1. We have x minus y equals 0. We have x plus y equals 30. They already give me the answer here, but that's not very satisfactory because we want to see how they got that answer. After all, you're not going to see the answer in your homework. I'm the instructor. I get to cheat and see the answer. You don't get to do that. So I need to show the work. Indeed, if you were to plug 15 and 15 in here, as I get to cheat and see, 15 minus 15 does work and give you 0. And it does 15 and 15, they both do add to 30. But you guys are not going to get to cheat. So how does this work? How do we solve this? Because you guys are going to have the blinders on and you all are not going to be able to see the answer. You're only going to be able to see the problem after all. Well, let's give it a look. There's your syllabus. Give it just a moment. Well, here's a problem that I did earlier today, but we don't want 76, we want 30. So x plus y is 30, and x minus y is 0. So with my former class, I did 76. Now with you all, I'm going to do 30. So what I do is I'm going to take these two equations now, and I'm going to consider the fact that I have plus y here and negative y here. And that begs for me to add these two equations. For if I add these two equations, the positive y and the negative y will annihilate one another. And that will just leave x all by itself. And that's good because I had prefer an equation with just one variable instead of two variables. So if I add these two equations, I get x plus x is 2x. Positive y and negative y, that was the whole reason for doing this process. They cancel. Now 30 plus 0 is very nice. That's just 30. So there we are. 2x equals 30. Now again, we're doing 30. Now I need to divide both sides by 2. And I get 2x over 2 is 30 over 2. The 2's cancel, and I get x. Now 30 divided by 2 is 15. So there it is, we get 15. Now x is 15. Now we have to remember, if x is 15, we have to go back and plug it into one of these two equations. It doesn't matter which one, really, to be honest with you. Let's just pick the bottom one since it looks so nice. 15 is x, and x minus y is 0. So plug in 15 into x, I get 15 minus y equals 0. Reference in this equation here. Now remember, in algebra, you add y to both sides, plus y plus y. You're used to doing it vertically, but I don't have very good tools for doing that quickly, and I want to do it quickly, so I did it horizontally. So plus y plus y. And what that's going to amount to is this negative y here and this positive y here are going to cancel each other. That was the whole motive for me doing this. But now the collateral price that I have to pay is I have to do it over here. After all, I want to get my y separate from my 15. And I get 15 equals y. I want to solve for y after all. So y equals 15. Well, what about it? We have found that x equals 15 and y equals 15. Excellent. So if x and y are both 15, well, we need to put it in ordered pair format. So x comma y is just the ordered pair 15 comma 15. They lie on the line y equals x, by the way. Actually, the point 15, 15 lies on the line y equals x, I should say, much more accurately. When I say they, I should have said it. Okay. The point 15, 15 lies on the line y equals x. Well, now let's look at another equation. 6x plus y equals 22. Neg 6x plus y equals 22. Again, when I have a term and it's exact negative, I want to add them surely enough. And I add the two equations on account of that. The 6x and negative 6x, I just want to add them. Now, this isn't the only thing I could do. I could subtract the two equations and cancel the y's, but I'm just in the mood to add them. You have choices here, but my choice is to add. Now, I add these two equations, and I get 2y equals 44, because y plus y is 2y, and the 6 and neg 6x cancel, and 22 plus 22 is 44. Okay, and indeed, that's excellent, because now we have one equation with just one variable, and the nice part being having the one variable. So that's excellent. We can solve for one variable all day. And indeed, we divide both sides by 2, and we get y equals 22. And so we take that 22, and once you've found one of the variables, you can find the other variable much more easily by taking the y equals 22 and plugging it into either one of the two originals, doesn't matter which, and solving for x. X is the other variable. So plug 22 into either the y. Let's just say the top equation, that's what I chose. So plug 22 into y, and we get 6x plus 22 equals 22, top equation, substituting 22 into y. Now remember, we want to get 6x by itself, so I subtract 22 from both sides, and I did it horizontal style. I know in grade school or early high school, you did it vertical style, but you'll just have to humor me. And indeed, I'm going to cancel 22 and minus 22 horizontally by associativity on the horizontal. You'll just have to get used to that. Now, on the right side, we get very lucky this time. We get 0. 22 minus 22 itself is 0. So 6x equals 0. But now 6x equals 0, I'm trying not to have too many ticks. We divide both sides by 6, and we get x equals 0. Now be careful. Anytime you do an ordered pair, you always have to put x first. So we have 0, 22. The x-coordinate, again, always has to come first. Never put the y-coordinate first. Okay, I still have a little bit of time left, so let's do this problem here. And this one is more tricky, but we can do it. 5x minus y, and sometimes when they have minus 1y, they'll just put minus y, so be on the lookout. So equals 49. And we have 3x minus 7y equals 23. Now the trick of a problem like this is to do the least common multiple, called the LCM, of 5 and 3, and that's equal to 15. Now, so I want to turn 5x and 3x each into 15x. So to turn 5x into 15x, I need to multiply it by 3. To turn 3x into 15x, I need to multiply it by 5. So I do so. I distribute 3 through the top equation. I distribute 5 through the second bottom equation. And I get 15x minus 3y equals 147. It's 35. Well, okay. Now, that's going to actually be 35 minus 3 is, yeah, that's 32y. Sorry, guys. That's 32y. Oops. Sorry about that, guys. But when I distributed the 5 through, I was thinking about 3, not 5. I was doing 3 times 7 in my mind. That's 35. Sorry about that. So I need to be divided by 32. I get a much prettier. So that's going to be neg 35, which is positive 35. 35. And then 35 and negative 3 make 32. I just got clumsy there. My bad. I'll try to edit this in the video. Y equals 1. Now that's a lot prettier, isn't it? Now I take y equals 1 and I plug it into either equation. Let's just say I plug it into this guy. I'm over my clumsy spell. So if I plug y equals 1 into this top equation, so 5x minus y equals 49. I try not to make clumsy errors, but they happen. So I'll catch them. Okay. Well, ideally, they don't happen. So we have that. We replace, well, y equals 1, so put 1 in there. Now add 1 to both sides because you want to counteract. So 5x, and then the negative 1 plus 1 fizzle over here, and you get 50 over here. Then you get x equals 10. Okay, so there's 10. X is 10. Now, when you write the ordered pair, be sure to put the 10 first because it's the x-coordinate. So it's 10, 1. Okay, well, we finally made it. So it's 10, 1. And that's good. I'm going to stop the video here, and I'll do more problems a little later. And I'll see you guys in a little bit. And let me stop the video.